Okay, thanks Ufuk for that stellar introduction. And thanks for organizing, Ufuk and Philippe. So let me give a quick intro on this paper, The Patent Troll, Benign Middleman or Stick-Up Artist. You might see something that makes it a little bit in common with most of the other papers here today, which would be the second author, Ufuk, and also Gökhan is a Penn grad student. So to introduce it a little bit, especially for non-North Americans, where this has been a really pressing issue and has yet to be in Europe, let me tell you what a patent troll or a non-practicing entity, an NPE, or a patent assertion entity, a PAE, is. These names sometimes get used interchangeably, sometimes distinguished, but essentially these are firms that buy patents and don't produce anything. And they make their money either by suing people who infringe their patents or by licensing their patents to firms that want to use them to make things. So that's what we're going to be talking about here. It's a very big interest in the US because there's been an increase in them in the last decade or so, and just in the last year or two, there's been a lot of discussion and legislation introduced into the US Congress and even to some state Congresses to try to combat them, because there's a perception that patent trolls or NPEs are bad for innovation. So we're going to try to investigate this perception. Number one question we're trying to get at here, and we're going to move in that direction. I won't say we'll answer it fully today. Are NPEs good or bad for technological progress? It's a tough question to answer because it's very hard to get data directly on NPEs. They are, by their nature, secretive entities. They use shell companies a lot. They don't really want people to know exactly what they're doing. So it's tough to get evidence. Therefore, most of the work, all of the work that I know of so far uses indirect evidence, like looking at litigation, looking at lists of likely NPEs and trying to look at characteristics of their patents. We are lucky that we got data directly from NPEs on lots of patents and information on how they monetize them, how they license, etc. So we're going to try to look from a different angle, kind of from the inside at the NPEs, and see whether that can help us get at the big, important policy question, whether something needs to be done about them. Your view on whether something needs to be done about them depends on where you fall on the two leading theories of NPEs, and we characterize them as the benign middleman and the stick-up artist. The benign middleman is just a market intermediary. In this case, it's a market for innovation, but it could be any other market. It could be a product market, where generally we think market intermediaries serve a useful role. They can help connect buyers and sellers, they can lower information costs, and they can do other productive things. So that's one perspective, tends to be held more by economists than by practitioners, especially practitioners who work in Silicon Valley. They tend to like the stick-up artist theory a lot more, and don't get me wrong, there's certainly economists, especially a lot of law professors, who like this theory, and that says that these firms, the NPEs, are just making money off of rents. They're taking advantage of weak patent laws, poorly granted patents, and they're asserting them in order to make a quick buck, and they're not providing any actual welfare gain to the world. So we're going to try to see if we can distinguish between these two theories with some empirical evidence. All right, so this is the outline. That was the motivation. I'll give you a very quick background, and then we'll jump into the theory, spend a fair amount of time on the data, because I think that's pretty unique here in our empirical analysis, and then we'll see what we've learned. So one slide on background. First, I want to let you know that we're not claiming that we're describing all NPEs. We're going to describe a very small subset of NPEs, but a pretty important one. Important because the ones we're talking about are extremely large. They're some of the largest ones. Therefore, they account for a fairly sizable percentage of patents held by NPEs. And they tend to be focused on the technology sector, where the debate has been hottest. So while it's going to be a focused study, it's going to be, I think, the place where we're focusing is of pretty high interest. They're not going to be ones that you may have heard of in the news, like there are some very small, pretty clearly bad actors that have patents. Like there's one that has a patent on a barcode scanner that every corner grocery store uses now, and they've gone and sent letters demanding several $1,000s to every corner grocery store in the US. That's not the kind of entity we're talking about. We're talking about larger, more sophisticated aggregators of patents. How they work is they tend to acquire patents in small groups, either from individuals or firms. And where they acquire them from, they're almost always the original assignee, so they're the inventors of the patents. They tend to buy them outright, and then they make money by licensing them out. They license them oftentimes in relatively large portfolios. It could be hundreds or thousands of patents even. They occasionally litigate over infringement, but that's a tiny share of their revenues, and we're going to focus here on their licensing revenues, since that is the vast majority of it. So that's their basic business model. Those are the NPEs we're talking about today. Okay, so let's see if we can understand maybe a little bit about how NPEs might impact a market for innovation. So just some background assumptions that we're going to use in the model. We're going to assume each patent has a litigation risk and a goodness of fit to its user's portfolio. I'll define that in a minute. Each firm is also going to be heterogeneous, like the patents. It's also going to have a location in a technology space, the same space that a patent is going to have a location in. And then size, which will impact its bargaining power. Size, we're going to proxy here by size of its patent portfolio. And then we're going to introduce an NPE. The NPE is going to be special in that it's going to have a big network, and that's going to allow it to more quickly and easily and cheaply locate potentially better users of a patent. And it's also going to be bigger and have more experience with litigation and with negotiation, and that will give it greater bargaining power than an average firm. Okay, so we have a simple static model. We're going to start with the production function you see in front of you, where K is quantity, and Q is the productivity or quality of an intermediate good. So for now, we're going to take Q sub I as given for the firm. Then we're going to change that in a moment, and it's going to just do profit maximization. And if we do that, skip a couple steps, we're going to get equilibrium profits for the firm to be proportional to QI, this level of technology or quality. So both profits and sales are going to be proportional to QI. So from here forward, we'll proxy for size. So size, profits, sales are all going to be collinear. So we might use those interchangeably. Okay, this is a circle of circumference 2. We have it because it's going to be our technology space along which firms are going to be located. And this is going to represent the location of their patent portfolios. So firm I and firm K are in this technology space, so the maximum distance apart they could be is 1. And firm I invents, and it comes up with a patent Z. And you can see Z is pretty far away from firm I in technology space, so it's not super useful to firm I, and I'll quantify that in a minute. We're going to say it's distance DI from firm I, but it's closer to firm K, D sub K, and therefore we're going to assume it's more useful, more valuable to firm K. So if the patent Z that firm I came up with could be sold to firm K, it'd be a Pareto improving trade. I'm going to skip a lot of terminology we use and tell you a little bit about what I said I would, how technology improves here. So this is the basic equation. It tells us how quality for a firm improves. So you start off with QI. You can come up with a patent, which occurs through a stochastic process, and that can increase your quality, which again increases your sales and your profits, according to that function, where D, importantly, is the distance of the patent to the firm. So what does this mean? If you come up with a patent that's closer to you, you're going to improve your quality more. If you come up with a faraway patent, it's not going to help you too much. Gamma is just going to be a scale parameter, and we're going to normalize it to 1 at somewhere, so you'll see it drop out at some point. So therefore, we can calculate the incremental profits from a new patent to be proportional to the distance that the patent is, or 1 minus the distance the patent is from the firm. Okay, we're then going to allow patents to be infringed, and there's going to be some exogenous probability alpha of infringement, and then we're going to have a competitor, J, that's the potential infringer. It's going to make profit omega sub J if it infringes. When I gets its patent infringed, it loses its profit, so it goes to 0, unless it goes to court. If it goes to court, it's got some probability of victory, rho, and if it does win in court, J, the infringer, is going to have to pay pi times 1 minus di, which is the profits that I would have made if there weren't infringement. We've now normalized gamma to 1, plus omega sub J, which is the profits J made, are going to be foregone. So it's actually is a little bit misleading. J is going to lose this amount. Omega sub J is just going to be foregone, and pi times 1 minus d is going to be paid to I. So that's what would happen if they went to court, but of course there are court costs, and there's a possibility for the firms to bargain instead of going to court, which they're likely to do, and we assume that they bargain with Nash bargaining of equal bargaining power. We're going to assume that the probability of winning a court case, rho, is increasing with firm size Q. So the first derivative of rho with respect to Q is going to be positive. Seems reasonable. Bigger firms have more heft, have more experience, more likely to win at court. If a firm doesn't go to court, it can also sell its patent to an NPE, and then it'll be the NPE's job to pursue firm J. As I mentioned, the NPE's got 2 advantages. There are 2 reasons why it might do a better job, why you might want to sell to it. First, it's got bigger bargaining power, so even before court, you might want to sell to the NPE so it can extract more of the surplus. And second, it's got access to a bigger network of customers that it can reallocate the patent to. So if we don't go to court, you still might want to sell to an NPE because it can get it to a more productive firm. Yeah.
So far, no licensing by the inventor in the model. Did I understand
the inventor, right? So we can add that. So the inventor can transact directly with another firm, but so we think basically the role of the NPE is to lower transaction costs. So if we assume the NPE is good at its job, we won't really see much direct licensing between firms, but we can add that.
Okay, but the ownership can be transferred to the NPE before anybody infringes or only after infringement?
Let me show you. This is perfect timing. So this is this is our game tree. So the first thing that happens in time is that the patent is discovered, or the patent is granted, and it's of distance di from original firm I. And then I has a decision to make whether to keep its patent or sell it to an NPE. If it keeps it, then infringement can happen with probability alpha. If infringement occurs, the only way I can get its money back is by either going to court or settling. If it goes to court, there's some probability of victory. It's a function of rho, and it will gain an expectation VI court. If they settle, they'll save costs of litigating and split through Nash bargaining and settle for a payment of PJ sub I. So this is going to, in this model, the firms are always going to settle through bargaining rather than go to court. If there is an infringement, then the firm is just going to produce, because I is a producing firm, and it's going to get the production sub I. Okay, so that's all if I keeps a patent. If it sells a patent to the NPE, there's still the probability of infringement, but now the NPE goes to court. And when the NPE goes to court, this is the expected judgment it gets, which is greater, we assume, than V court sub I, because the NPE has greater litigation experience and greater heft, so it'll increase its probability of victory at trial. So that's going to be bigger than that. If they settle, the NPE is also going to be better at that because it's got a higher threat point and also higher bargaining power. NPE cannot produce itself, though, so if there is an infringement, it's going to have to license to someone else, to a firm K, to make it, but it's going to use its network to license to a firm where D sub K is smaller than D sub I, and so it should be able to get PK sub NPE. So this is the outline. This is the structure of K.
Yeah, so is there a notion of abusive litigation or abusive licensing in your model? Because that seems key for the sticker artist theory.
So far, no. We're not going to have, tell me a little bit more, so what would be abusive?
So for instance, the NPs litigate weak patents that should not have been granted, patents that don't have commercial value, but they're going to basically impose a tax on the existing firms that produce, have valid intellectual property, but they actually don't want to go all the way to litigation, so they're going to settle. So the NPs are there, but just abusively litigate or license weak patents.
Yeah, so I can think of a few ways you might model that, either, some risk aversion, if you want, for some of these companies, or some probability that, invalid patents are still going to be upheld. For now, we're not including that in our base model. We're going to assume, we're going to still allow NPEs to do some potentially harmful acts, but not through abusive litigation. I'm going to mostly skip through how we get here, but we can solve the game tree, and we can get expressions for the price that an NPE would pay for a patent, so down here, and the probability that a company would sell to the NPE. And these are the expressions up there and down there. And what I'm going to do, though, is skip to the comparative statics, because this is going to now move us in a minute to the empirical part, and we'll go into the data and see if we can test these things. But basically, we're going to have a number of predictions of our model. So first, the NPE is going to be more likely to buy patents from small firms, which kind of makes sense because small firms stand to gain more from the bigger heft of the NPE. Second, the likelihood that the patent of a patent sale is going to increase in the distance of the patent to the initial innovating firm. So initial innovating firms that come up with patents that are far from them are going to be more likely to sell to an NPE. It's a less valuable patent to them. They can take advantage of the NPE's network. And then we're going to find that that effect is even more pronounced for large firms. Since they're bigger, it also means their profits are bigger and they stand to gain more from the sale of these distant patents. Next, we can think about the likelihood of a sale, the probability the patent gets sold to an NPE. And that's going to increase with litigation risk, the likelihood that a patent gets infringed. And again, that's one of the ways you gain from an NPE is by using it in litigation. And that likelihood is going to be more pronounced for small firms. Again, they're the ones who can gain more from the NPE's heft. Do you have a question?
Quick clarifying question. So how do the NPEs find the firms they would license to? And why would they not want to just license to the firms who might be infringing upon their patents ex ante? Is there a reason why they wouldn't just find the guys who are the most productive use of the patents, who are probably the guys who most want to infringe?
Yeah.
License to them ex ante?
Okay, so far that's a black box, how they find. So we're just assuming they have a technology to, like this is their business, is having networks that lowers the cost for finding counterparties. So they absolutely could license to an infringing firm. If we go back to the game tree for a second, I mean here, just based on the order of things in our model, the infringement either happens or doesn't happen before the licensing decision occurs. So that's just a structure, part of a modeling choice here. But Ufuk wants to add something.
So if there's an infringement, you license it to the infringer, basically. You extract grants from that firm and you license it to whoever is infringing. If there is no infringement, then either the initial originating firm can use it if it's a good match, or if it's a bad match, then and you can sell it to NP, and NP can find it a better user. So if in case of an infringement, you don't go and look for a better user. You direct the deal because that's the source that you can extract money from, basically. So then licensing is happening with the infringing party.
So just again, then there is no going to court cases, like it's always resolved?
Well, in equilibrium, they'll always just settle. Okay. Let me give you a few more comparative statics. We can think about the price that a licensee will pay to the NPE. So this is now kind of the second part of what the NPE does. Buys patents from originating firms, license them out to licensees. That's going to be decreasing with the distance to licensee, because the farther a patent is to a licensee, the less valuable it is. And it's also going to be increasing in the litigation risk. The more likely that a patent gets litigated, the more valuable it is to a company. We've got three more, and then a couple more. So we're also going to see that the acquisition price price at which the NPE buys the patent is going to decrease with distance. So larger distance going to be equal to lower price. It's got an ambiguous relationship with litigation risk, and then NPE is going to pay more for large firm patents because they have higher negotiating power. We want to do one more thing and then get to the data, and that's think about subsequent innovation, so downstream innovation with or without an NPE. So we're going to assume firms make a decision about the rate of innovation, that's mu sub j here. This is kind of downstream firms that can decide whether to work in the same area that is infringed potentially on an earlier patent. And they're going to choose mu sub j to maximize this function. It's basically the expected profits they get when they get away with it minus the amount they pay to either the originating firm in the top version or the NPE in the bottom version for settlement, and then minus the cost of innovation. The maximization is going to give us these expressions from u sub j without the NPE, and then with the NPE, and then, whoops, well, we don't have it. We can put those two together and basically see that here the NPE is going to have a pernicious effect because we're going to have a lower rate of innovation, basically because the NPE is going to extract more money from the downstream firms. Downstream firms are going to innovate less, and so the NPE is going to hurt subsequent innovation. So this brings us to our last two comparative statics. We expect follow-on innovation to drop once an NPE purchases a patent, and this to be stronger for larger subsequent firms and more valuable innovations because just the magnitudes are bigger. Okay, so.
Did I understand right that with an NPE, the allocation of patents is improved? You get better matches with the users than without an NPE, but you're essentially assuming that has no impact on follow-on innovation. So it's just the price effect, but the fact that you get matched with a better patent doesn't improve the downstream innovation ability in the subsequent stage. You're assuming that away.
I think that's right. Right?
Normally there's a detrimental effect when there's a litigation risk, but in terms of the improvement, so that will not have any subsequent effect.
All right. Now I want to spend the rest of the time looking at the data. I'll start with telling you what we can't tell you, and that is because of.
So just one last question about the model and the connection between your comparative statics and the initial question, which is we want to distinguish between these two theories about the role of NPEs. So is it right that what you're trying to do is you have derived a series of comparative statics that are consistent with the notion that NPEs are these middlemen, and you want to test in the data whether these comparative statics hold, right? Or is I could not see in your model whether there were comparative statics that were speaking to the other theory, which is the inefficient holder of patents theory.
Yeah.
And also I wonder why these comparative statics wouldn't be consistent with the other theory. So if I do abusive litigation, abusive licensing, these comparative statics could still hold. So I will be trying to extract rents. I will be able to do so less efficiently when the distance between what I hold and what the firm is active in increases. So the comparative statics could, I think, hold even under this inefficient forms of licensing and litigation.
So let me partly defer this until the end because I think we're going to talk about it. We're going to talk about when we look at the conclusions. Actually, let me wholly defer it till the end because I think that's exactly the right question to ask. But at the end. So let's look at the data. Okay. So I told you. So I can't tell you I can't tell you where the data comes from because of a confidentiality agreement or the exact level of revenue, but we can still tell a lot of information about the data sets, and I'll show you some summary stats very shortly, including that we have tens of thousands of patents and patent year licensee level revenues between 2008 and 14. So this is some descriptive statistics for, on the left panel, the NPE patents, and on the right panel, the comparable patent universe. And by comparable, I mean same technology classes, so weighted by the technology class and age distribution of the NPE patents to try to get rid of at least some of the most obvious sources of differences. Let me just define a couple things for you that might not be immediately obvious. We'll come back to that in a second. So first, hotness is the percentage of backward citations to patents that are at most 3 years older than the citing patent. By the way, I should say for non-patent statistics regulars, patents are just like academic papers in that they cite prior art and they also are cited by future patents. When you cite a previous work, that's called a backward citation. When something cites you, that's called a forward citation. A lot of work makes the assumption that especially forward citations, subsequent citations to a patent, are a measure of the patent's value. There's certainly a measure of how much work is impacted by it. And some work also uses even backward citations as some measure of value or something. We're going to have to normalize for age, since these patents are going to come, some will be very new, some will be very old, and therefore have longer to have collected forward citations. We're going to normalize that by creating a citation age profile by technology class, and then multiply the number of forward citations a patent has by the fraction of time or fraction of expected citations it's already, the average patent in its technology class has accrued. For litigation risk, we're just following a paper by Lanzhou and Schenkerman, and going to use the measure they constructed for that. And entity size, whenever I say that, I'm going to mean the firm's patent portfolio size. Okay, so one more important definition, patent distance. So again, this is an important metric for us. We're going to use it to figure out how far apart a couple patents are, how far apart a patent and a firm are, how far apart even firms are. It's all going to be based on this, the overlap of citation to a patent's two-digit IPC class. Basically, the intuition is this. If the overlap, so if you have two patents, PX and Y, in classes X and Y, if the number of patents that cite both of them is the same as the number of patents that cite either of them, that means they have exactly the same overlap. The numerator and the denominator are going to be the same. The distance will be 0, minimal. If they have two patents that have completely disjoint set of citations, the intersection is going to be 0, and the distance will be maximal 1. Okay, so now that we know all these definitions, we can take a look at the summary stats and just highlight a couple things here. So one, the NPE held patents have a higher mean distance from the originating entity, so they're farther away from the original entity if they end up in the hands of an NPE. Two, the originating entity size, the log of the originating entity size is way smaller than the mean originating entity size. So patents that end up with NPEs are going to be much smaller than the universe. Three, there's substantially higher litigation risk, and they have much higher number of forward citations and backward citations compared to the average. Some of this is already previewing the test of the comparative statics that we just talked about. Okay. We can also look at summary statistics at the acquisition deal level. So this is now one observation per acquiring deal, and there can be multiple patents acquired at once. Usually it's a handful. There's not too much I want you to focus on here by itself, but what I do want to do is compare this to this table, which is summary statistics by licensing transactions. So this is the other side. This is after the NPE has acquired the patents and then is licensing them out to firms. And it's at that level that this is summarized. I just want to focus on the two things. One is the distance to the licensee, and the other is the log licensee size. So here the distance mean is about 47, and the size is 6. Here, the acquisition size, the acquisition deal, the mean distance is about 32, and the originating size is about 3. Okay, so two things to note. So one, the mean distance seems to go way up from the acquisition to the licensing, but also so does the entity size. If we think about the originating entity to the entity that ends up with the licensee. This might worry you, this worried me, the fact that it seems like patents are ending up with much larger distance than they started out with. That seems to really directly undermine the idea that patents are benign middlemen if they actually are ending up with firms where they're way more distant, and in our model that means way less valuable. That is not a good story for them. So that would be true if distance was invariant to entity size. It turns out, well, that x-axis is originating entity size. Our distance metric is not invariant to entity size. It increases substantially with it. I don't have the slide right here, but if we compare the patents that licensees end up with versus a random draw from the PTO universe of same technology class and same originating entity size, the ones that they end up with are substantially closer distance to the licensees than a random draw. So this is a little bit of evidence that the NPEs are doing something in this reallocation process. They're helping licensees get patents that are a little closer to what they do. Okay, now I'll spend the rest of the time just going through some regressions to test the comparative statics, and then we'll come back to your question and talk about what this all means. Yeah.
So a question about the data. So you went pretty fast on what these entities are, and so I understand that there are lots of restrictions due to your confidentiality agreements.
Yeah.
But it does seem like a crucial part of your paper to make the case that somehow this data is representative of what NPEs do more broadly. So why are there reasons to think that indeed the entities that you got data from are representative from NPEs as a whole? And if so, what kind of NPEs? Are they more like intellectual ventures? Are they more like failed companies or companies that don't really produce anymore?
You may have missed the beginning of my talk, so so let me just say it again. We're not trying to say this is representative. We're saying these are some of the biggest type of NPEs. So it's not representative of all NPEs. Nothing is representative of all NPEs because there's a ton of heterogeneity in what they do. It's an important subset of the NPEs, and that these are some of the largest ones out there. They have some of the largest portfolios, and they're also in the sector technology, where there's the biggest controversy about this. This is kind of the stuff Silicon Valley gets all up in arms about. So we're not going to claim, based on this data, that you can make some blanket conclusions about all NPEs, but we're going to be looking at a very important part of the NPE world.
Okay. And do they give you all the patents within their portfolio, or is there also selection within these entities?
We have all their data. Okay, so the tests. So the first 5 predictions were that the probability of sale is going to increase with distance from the originating firm further away patents are less valuable. That effect's going to be more pronounced for larger entities. They have relatively more to gain. The probability of sale is going to decrease with entity size. So meaning smaller companies have more to gain and are more likely to sell to NPEs. Probability of sale is going to increase with litigation risk because that's where NPEs, one of the places they have an advantage, and then that effect is going to be more pronounced for small entities because they have less heft.
What do you mean by that?
The last one?
The last one.
Yeah, so that the previous line, that the probability of sale increases with litigation risk, that it's going to be, the slope is going to be even greater for smaller entities. This is a regression of all patents in the universe for the same years that the NPE held patents exist. The dependent variable for each of these regressions is going to be 1 if the patent is sold to an NPE and 0 otherwise. We're going to control for a bunch of different characteristics, including technology category, application year, and a number of other patent characteristics. And let's go to the tests. So first, we find the log originating entity size. The bigger the originating entity is, the smaller the likelihood that a patent gets sold to a troll. Small entities gain more from the sales. Second, we're going to look at the distance to the originating entity. We're going to find a positive coefficient, so patents that are further away from the originating entities more likely to end up in the hands of NPEs. Third, the interaction between entity size and distance, basically the previous one but interacted with distance, that's also positive. So bigger firms are going to, bigger firms are going to gain relatively more by selling their distant patents. Litigation risk, higher litigation risk patents are more likely to end up in the hands of NPEs. And then the interaction between litigation risk and entity size, that's going to be of less additional value for smaller firms or for larger firms, or more valuable for smaller firms. So one thing you might get from thinking about these together is that small firms, and this is a story that often gets told, small firms can't stand up for themselves a lot of times if their patents get infringed, or they might not be interested or able to monetize their patents by producing, and they're better off selling to NPEs. They can gain potentially by the reallocation they do.
How should we think about the magnitude of the coefficient? Are they large or small?
That's a good question. That I don't have a great answer to right now. I don't have the slides on it. We do have tables on it. So let me see if I can think of a good comparison for you. So something like a 1 standard deviation. So these are not normalized here. So we're working on revising the table so that we have normalized coefficients everywhere. These are not normalized, so it is very hard to interpret. But if you say look at a standard deviation increase in litigation risk, the probability of sale to an NPE increases by, I don't remember the exact numbers, but like half of a standard deviation, something like that. I can tell you. So I'd say all of these are pretty meaningful, but not nuts. But these coefficients here, I'm afraid, are hard to interpret directly. Yeah.
For instance, just back of them, or in a very casual way. If you think about no litigation risk to 100% litigation risk patent, for instance, if you take a look at the first one, increases the probability by 0.18, given that on average, 0.18% of the patents are being sold, so it doubles basically. It's a very sizable effect. So it doubles the probability of getting sold quantitatively. On the spot, I'm making this back of the envelope calculation, but of course in the paper there would be more detailed of these.
I think that's the correct interpretation. Though there have been some recent changes. Okay, let's. Yeah.
Did you try creating the same table with a dependent variable that is just a sale to any firm instead of an NPE? Just to compare whether the structure or the collection distance are different for selling the patent to an NPE as opposed to any.
That's a good question. At some point, do you remember if we did that? We talked about that, and I don't remember if we actually did it.
No.
Okay, I think it's a nice suggestion. Just another way to get at some of what we see in that regression table is the distribution of originating entity size for NPE patents versus the universe. We see much more weight on much smaller patents for the NPEs than the universe at large. And litigation risk, we see a pretty clear rightward shift of litigation risk among NPE-held patents. Okay, so we checked off those predictions. We've got another couple of predictions to test about the acquisition price. We predicted that it's going to decrease with distance, and also that NPEs are going to pay more for patents that originate from large firms because of their bargaining power. We run a regression where the dependent variable is the log price that the NPE pays to acquire a patent. And I'll just focus your attention first on the first row, where we see a positive, significant impact of the log entity size. Again, the actual coefficients are a little hard to interpret here because we've multiplied them sometimes by 100 or 1,000 to make them more legible. So for now, let's just look at the significance of the relationship, and then we'll think about the magnitudes. Bigger originating entities seem to get higher prices for their patents, and then patents that are more distant from the originating entities come up with lower prices. Okay, so the next set that we want to look at has to do with the licensing fees that firms pay to license the patents. So first, we predicted that the licensing fee is decreasing in the distance. Second, it's going to increase in litigation risk. And third, that large entities are going to pay higher licensing fees because they have more to gain. This regression, the dependent variable is the log of the licensing fee that firms pay. So the first row, the independent variable is the distance to the licensee. The bigger the distance to the licensee, the lower they're going to pay. So again, if a licensee is acquiring a patent that's still pretty distant from it, it's not going to pay as much. Second, the log licensee size. The bigger the licensee is, the more it stands to gain from licensing and the more it's going to pay for the patent. And then finally, litigation risk. The more likely a patent is to be litigated, the more valuable potentially a license is. And that's what we find here. Okay, so we checked off these three. We're now going to do one last set of empirical results, which we're going to look at a little bit differently using an event study. This is about the downstream impact of NPEs. So we predicted that when NPEs purchase a patent, subsequent entry is going to decline, and that effect is going to be more pronounced for large entities and more valuable patents. So this is what we see. So this is an event study where the dependent variable is the number of forward citations received relative to time of NPE purchase. So NPE acquires a patent in year 0, and we're going to track how many subsequent forward citations the patent gets relative to that acquisition. So we find, on average, a decline after acquisition, although the stuff is pretty noisy, to be honest. We're going to see a more pronounced effect if we break things out by patents that are in the bottom decile of value versus top decile of value. We're going to find that all of this decline in citations is happening from the really valuable patents. So NPE acquires a patent, a valuable patent. Firms get scared off that if they work in that area, they might get sued or they might get asked to pay substantial licensing fees, and they don't work in the area and citations go down. And we can see something that's a little bit noisier if we break things down by large or small entities. We see more of the decline for large entities, but here there's too much noise to really tell much. Okay, so let me wrap up and then come to your questions. So we found a few facts. So one, NPEs are more likely to buy patents from small entities. Two, they're more likely to buy patents that are peripheral to an innovator's portfolio. Three, small entities are more likely to sell patents with high litigation risk. And then four, citations decline after NPE acquisition. So what does this tell us? So taken together, the first three facts seem to point to some support for the benign middleman. So again, they're buying patents from small entities that may not be able to monetize patents themselves. They're buying non-essential patents and reallocating them to places where they're more essential. And small entities are selling the high litigation risk patents. That all points, I think, to the benign middleman story. It's of this productive reallocation. The last one, though, of this citation decline after NPE acquisition, I think points a little bit more in the stick-up artist direction, where we see that the NPE is grabbing a share of the rents from the patent, and by doing so is deterring subsequent innovation because subsequent entrants are concerned about its heft in litigation. So we're still working towards overall welfare, which we'd like to do. We're missing one important piece, which is the ex-ante innovation incentives. What exactly is the NPE's presence and its ability to increase returns for small entities doing as far as their initial innovation decision? Do you want to add anything, or should we take questions?
I